So in this clip, we're going to look at a special case of doing work, which is when an object is lifted and work is done against the force of gravity to lift an object through a height, which we'll be calling h for the rest of the video. Now, the required force to lift an object, here's Percy sat on the rails. Okay, he has a weight which is equal to his mass times gravity. In order to lift Percy from the rails, we would need to supply a force equal to Percy's weight. Now, of course, you can use a higher force to lift an object, and that will then result in unbalanced forces and therefore the object accelerating through the air, which in reality, of course, is part of what happens. But what you'd also have to consider there is that the object would then have to decelerate back to rest. So we're looking at an average force here, really, which is still equal to the weight. So in order to lift Percy, we are looking at a force equal to the weight, mg. Okay, so Percy might be lifted by an object such as, if we bring it in, the breakdown crane. Okay, so if the crane was to lift Percy up using a force F, up to there, it would have lifted Percy through a height of h. Okay, if we clear the board, what that gives us is that the work done on an object, which we saw was force times displacement, is equal in this case to the force, which we said was mg, the weight of the object, multiplied by the distance it's gone through, which is delta h. Now the delta here is significant. What we've done is not given Percy didn't start with 0 gravitational potential energy. Okay, if we'd have removed the floor from under him, he still would have fallen. So he must have had some gravitational potential energy to start with. All we've done is change the value, and this delta signifies change. It's a change in height, and that work done is therefore equal to his change in gravitational potential energy. So we've got the delta on both sides. Most of the time in the equations, you'll probably just ignore that as you work through examples, but to be strictly correct, we've looked at a change in gravitational potential energy due to a change in height. Again, it's an energy, so of course it's measured in joules.